together, learn how to find the y-intercept and graph. So the y-intercept for a quadratic function is the same as finding the y-intercept on a line. You substitute 0 for x, you simplify, solve for y, and then write your y-intercept as an ordered pair. So our first example we have in factored form. So we substitute, see if I can get my pen to work here. Substitute 0 for x in both places. So x minus 3 becomes 0 minus 3, and 2x plus 5 becomes 2 times 0 plus 5. 0 minus 3 gives us negative 3. 2 times 0 is 0 plus 5 is 5. So our y-intercept is negative 15, or the ordered pair 0, negative 15. Second, we're going to look at finding the x-intercept in vertex form. Same thing, replace x with 0. And evaluate. 0 plus 5 is 5. 5 squared is 25. And 25 minus 6 is 19. So we have the y-intercept 0, 19. And finally, we're going to take a look at it in standard form. The simplified version of finding the y-intercept in standard form is just finding that c value. Remember, the coefficient of x squared is a, the coefficient of x is b, and the constant value is c. The reason this is a shortcut is because when we substitute 0 for x, our first term becomes 0, 2 times 0 is 0. Our second term becomes 0, 5 times 0 is 0. So we're left with just that c value. So in the future, when you see an equation in standard form and you're looking for the y-intercept, you can just give me the ordered pair 0, negative 6. You don't have to show any work. All right, now we're going to put all of the information that we've learned about quadratic functions so far together and find out how to graph them. So our first question is, does the graph open up or down? In this case, our a value is negative, so the graph opens down. Finding the axis of symmetry. Remember, in standard form, we use that equation x equals negative b over 2a. Our b value in this case is negative 6. The opposite of negative 6 is positive 6. And our a value is negative 1. So the axis of symmetry is x equals 6 divided by negative 2, or negative 3. Again, that equation in simplified form is merely x equals negative 3. To find the vertex, you take the x-coordinate for the axis of symmetry and substitute that back into the function. So we're evaluating f of negative 3. So it becomes negative 3 squared minus 6 times negative 3 plus 1. So our first term, negative 3 squared, is 9. 9 times negative 1 is negative 9. Negative 6 times negative 3 is positive 18 plus 1. So we have 9 plus 1, or 10. It's very helpful if you write this as an ordered pair for when we go to graph it. It'll be easy to put the information together. So the x-coordinate is negative 3, and our y-coordinate is 10. Solving for the y-intercept, replace x with 0. And actually this one's in standard form, so we can just take a look at that c value of 1. So our y-intercept is 0, 1. Domain for all quadratic functions is all real numbers. For our range, the graph opened down, so y is less than or equal to the y value of our vertex, which was 10. All right, so we're going to put all of this information together on the graph. First of all, our vertex was negative 3, positive 10. Our y-intercept is 0, 1. And what I like to do is use this axis of symmetry to reflect the y-intercept across the axis of symmetry, and that gives me another point on the graph. So the y-intercept is 3 units to the right, so I can graph a point 3 units to the left along that same line, the y equals 1. And then I can graph my parabola. Alright, so now we're going to take a look at graphing an equation in factored form. We'll start with, does it open up or down? This time this is our a value. It's positive, so our graph opens up. The x-intercepts in factored form, remember, look at the asylum. So it looks like x minus 1. We think that the x-intercept is negative 1, but it's really positive 1. And then we have x plus 5, so we know our x-intercept is the opposite, or negative 5. When it's in factored form, you have the x-intercepts. When you're finding the axis of symmetry, you average those x values. So the equation for our axis of symmetry would be 1 plus negative 5 divided by 2. Negative 4 divided by 2 is negative 2. So there's our axis of symmetry. I'm going to go ahead and write those x-intercepts as an ordered pair, so they'll be easier to plot when we have to graph. Alright, our next piece of information is finding the vertex. The vertex, remember, is where the maximum or minimum value of the quadratic function occurs, and it's the y value along the axis of symmetry. So the x value for our axis of symmetry is negative 2, so I'm going to substitute that into my function. So we have 2 times negative 3 times positive 3. Negative 6 times 3 is negative 18. So our vertex as an ordered pair is negative 2, negative 18. The y-intercept is when we substitute 0 for x. So we have 2 times negative 1 is negative 2, times 5 is negative 10. Domain is all real numbers. Range, because the graph opens up, will be y is greater than or equal to the y-coordinate of the vertex, which is negative 18. And finally, putting this all together for our graph. So I'm going to go by a scale of 2, since I have a vertex at negative 18. So my first x-intercept at 1, 0, I'm going to plot that at what looks like half 0. And then negative 5, 0 will look like negative 2.5. And then I have my vertex at negative 2, negative 18. My y-intercept at 0, negative 10. And I can reflect that across the axis of symmetry to get another ordered pair. Here's my axis of symmetry. So I'm going to flip that across the axis of symmetry. And this parabola is very skinny, so I'm going to try and draw this carefully. Again, parabolas have a U shape, so when you get a graph this skinny, make sure you're very careful that it looks like a U shape as opposed to the V shape, which is the absolute value. Last graph in vertex form. Does it open up or down? In this case, our A value is negative, so this one opens down. Axis of symmetry, because this is in vertex form, the axis of symmetry is that x-coordinate of the vertex. The x-coordinate of the vertex, it's in the asylum, so it's the opposite of what we think. So we have an axis of symmetry, x equals negative 2. It's in vertex form, so our vertex is negative 2. Remember that asylum. Outside the asylum is negative 3, so that's normal. Y-intercept, we're going to substitute 0 for x. And evaluate to solve for y. So we got negative 1/2, or negative 5/10 times 2 squared, or 4, minus 3. So we get negative 2 minus 3 is negative 5. So there's our y-intercept in ordered pair. Domain, all real numbers. Range, our graph opens down, so we have y is less than or equal to the y-coordinate for our vertex, negative 3. And we'll pull this all together for the graph. Our vertex is at negative 2, negative 3. Our y-intercept is 0, -5. I'm going to reflect that across the axis of symmetry. And we know the graph opens down. All right, so that is today's lesson. In class, we will be looking at graphing quadratic functions.